Okay, guys, we're back. And now in this video, we want to talk about how to solve proportions. And we already know how to do it pretty much. To solve proportions, we're going to use cross products. So let's just start with a basic equation. Solve this proportion, and if necessary, round to the nearest hundredth. So I have x over 10 equals 3/5. What you do is you take the cross product, so x times 5, and set it equal to 10 times 3. Rewrite it after you multiply, so 5x equals 30. And you know how to solve this equation now, right? That's a one-step equation. Divide both sides by 5, and you get x equals 6. Now, we can check this by simply plugging 6 back in. Is 6/10 equal to 3/5? Yes, because if you reduce 6/10, you get 3/5. You put it in simplest form. Okay, x minus 2 over 14 equals 2/7. So you have your originally create equation. Now you want to take the cross product, but you have to be careful here because when you multiply the means, x over 2 times the 7, you have to think of the 7 as multiplying everything in the numerator. So put the x minus 2 in parentheses so that you're reminded to distribute it. Otherwise, you'd probably write it like this and think, oh, that's going to be x minus 14. Or if you wrote it like this, you would think, oh, that's 7x minus 2. But really what you need to do is multiply the 7 by everything there, okay? So if you multiply it out, you would get 7x minus 14 equals 28. Now that's a two-step equation. Add 14, so you get 7x equals 42. And then divide both sides by 7. Forgot to put that on there. And you get x equals 6. Now, if you substitute 6 in, you get 6 minus 2 over 14. 6 minus 2 is 4. And in simplest form, that's 2/7, which is equal to itself, 2/7. So we're good. All right, here's a couple for you to try. Go ahead and pause the video and hit play when you're ready. Okay, we're back. So taking the cross product here, you get 40r equals 25 times 8. So 40r equals 25 times 8. Think quarters. How much money would 8 quarters give you? Yeah, give you $2. So that's 200. Divide both sides by 40. Now, a trick when you're dividing numbers that have zeros at the end, however many zeros they have in common at the end, you can chop those off. And the reason is because basically what you're doing when you do that is you're reducing it by a factor of 10. If they had 2 zeros, like if it was 2,000 over 400, you could chop off 2 zeros, which is basically like dividing the numerator and denominator, reducing it by a factor of 100, okay? So you basically have 20 over 4. All right, what's 20 divided by 4? 5, okay? And if you substitute 5 back in, you'll see that 5/8 is equal to 25/40. All right, 3b, take the cross product here. It's going to be 8 times x plus 4. And if you did 8 times x plus 4 like this, that's fine. It's not wrong. As long as you have the parentheses and you remember to distribute it. Equals 5 times 3. So, like I said, distribute the 8, you get 8x plus 32 equals 15. Subtract 32, and you get 8x equals negative 17. Oops, forgot the 1. Now, if you do it horizontally, 15 minus 32. Remember, keep, change, change. Keep the sign of the first number, change it to addition, and change the sign of the second number. So now I'm adding numbers with opposite signs, so I'm going to subtract the numbers and keep the sign of the larger. Since 32 is negative and it's larger, the answer is going to be negative 17. Then divide both sides by 8, and you get x equals negative 17/8. Okay? And that reduces, if you put it in a decimal form, it'd be negative 2.125. Or as a mixed number, it'd be negative 2 1/8, because 8 goes into 17 twice with 1 left over. Okie doke. but leaving it as an improper fraction in simplest form is good enough. Okie doke. All right. So the ratio of two measures having different units of measure is called a rate. For example, a price of 99 cents per 10 songs is a rate. The rate tells us how many of one item is being compared to one of another item is called a unit rate. So in the past 2 years, a retailer has opened 232 stores. If the rate of growth remains constant, how many stores will the retailer open in the next 3 years? So if you let R represent the number of retail stores, because that's what we're trying to figure out, how many stores will they open, not how many years. Okay, so think about it. The two units involved in the problem are going to be important. Number of stores and number of years. Those are the two units being compared here. So write a proportion for the problem. Okay, what are the two numbers that we know with the units that we can set up a ratio? Well, we know 232 stores per 2 years. So 232 stores over 2 years would be our first fraction. Then the second one you set up using the variable and the other number that you know, but make sure you set up the same fraction in the same way with the units, the same units in the numerator and denominator as your first fraction. In other words, you're going to have R representing retail stores, so that has to be in the numerator because the way you set up the other fraction, you had retail stores in the numerator. You don't know the number, so we used R. And you could have used X, Y, or Z, but we used R because R goes with retail. And then the denominator is over 3 years because I want to know how many will we open in the next 3 years, so I know the denominator is 3. Okay, so we set up the proportion, take the cross products, and you get 696 equals to R, divide both sides by 2, and you get 348. So then that's the number. What's that mean in the context of the problem? So that means the retailer will open 348 stores in the next 3 years. So if they can continue to open 232 stores every 2 years, then in the next 3 years, they will be expected to open 348 stores. Okay? Cool enough? All right, here's one for you to try. Go ahead and read through the problem and hit play when you're ready to check your answer. Okay, we're back. So it takes 7 minutes for Isabella to walk around the gym track twice. At this rate, how many times can she walk around the track in a half hour? So the two units involved in the problem, you got to figure these out, are minutes and walking around the gym track. We'll call those laps. So there's two ways you could set it up. You could do 7 minutes over 2 laps, or you could do 2 laps every 7 minutes. It doesn't matter which way you do it. I'm going to show you how to do it both ways, just as long as you set up the other fraction the same way as you set up the first one. So at this rate, how many times can she walk around the track in half an hour? What's half an hour? Since our units are minutes, how many minutes is that? It's 30 minutes. So I know that it's going to be 30 minutes over, do I know the number of laps? No, so I'm going to use capital L for laps. Okay, then you would take the cross product here. So 7L equals 2 times 30. 7L equals 60. Divide both sides by 7, and you get L equals 8.6 if you round. 8.6 what? Laps. So if she walks at the rate of 7 minutes for 2 laps, then in 30 minutes she can be expected to walk 8.6 laps, so a little bit more than 8.5 laps. Now, if you set it up the other way, 2 laps over 7 minutes, then you would do L laps over 30 minutes. That's an I. And then you take the cross product there. So 2 times 30 equals 7L. 60 equals 7L, divide by 7. You get L equals, put a long equal sign because you get the same thing. Okay, it doesn't matter which way you set it up, again, just as long as you set up both fractions the same way. Okie doke. All right, a rate called a scale is used to make a scale model of something too large or too small to be convenient at actual size. So when they're making models of cars or models of buildings or bridges, oftentimes they use a scale model, which is a smaller one that they can like fit in the office so that they can look at what it should look like in real life without actually having to build the whole entire thing, because you can't like carry that around. So the Ramsey Cascades Trail is about 1 1/8 inches long on a map with a scale of 3 inches equals 10 miles. What is the actual length of the trail? So again, same thing as rates. You have 2 units involved. What are the 2 units? Okay, well, the scale on the map is inches. In real life, there's miles. So we're comparing inches and miles. So we're going to set up the fraction of the 2 that we know and set it equal to the fraction of, or the ratio of the 1 that we know and don't know. All right. So if you let L represent the actual length, you can do scale over actual. So the scale is 3 inches per 10 miles, and that's going to be equal to the scale, which on the map, the trail is 1 1/8 inches, times or over the actual length, which we don't know, so we use L. Take the cross product. 3L equals 1 1/8 times 10, and that'd be 45/4. So here's how we did that. 1 1/8, you want to convert that to an improper fraction. And how I like to do it is like this. So if it's in eighths, that means you need 8/8 to make a whole. Since you have one whole, you would do 8 times 1. So that tells you how many parts you'd have in one whole, be 8. And then add the 1 extra eighth, which would give you 8 plus 1, which would give you 9/8 times 10. Okay, and if you put the 10 over 1, now where'd the times 10 come? That's from the times 10 here. So 1 1/8 as an improper fraction is 9/8 times 10. You could cross reduce and do 4 and 5. And then so multiply straight across. 9 times 5 is 45. And 4 times 1 is 4. Okay, divide both sides by 3, and you get L equals 15 over 4, or 3 3/4. So the actual length is about 3 3/4 miles long. So sound pretty good, huh? All right. Okay, here's one for you to try. Go ahead and pause the video, hit play after you've read it and tried it out. All right, we're back. So on a model airplane, the scale is 5 centimeters equals 2 meters. If the model's wingspan is 28.5 centimeters, what is the actual wingspan? So I'm just going to set it up 5 centimeters over 2 meters. So that's scale over actual. If you did actual over scale, your fractions are just going to be flipped of what I wrote. I'm not going to go through both ways here. Now, the 28.5, where does that go? Numerator or denominator for how I set it up? Right, the numerator. So 28.5 centimeters. And that's over W meters, all right, for wingspan. Okay, now let's cross multiply. 5W equals 2 times 28.5. Okay, so 5W equals 57. Divide both sides by 5, and you get W equals 11.4. But in the context of the problem, the 11.4 means something. What is it? Well, it's 11.4 meters. But still, we put the units on it. Okay, but what's it mean in the context of the problem? That means that if the model's wingspan is 28.5 centimeters on the scale model, the actual wingspan of the airplane is going to be 11.4 meters. Okie doke. All right, guys, that's it for this section. Please continue on to your assignment. As always, reach out to me if you have any questions, and make it a great day. Take care.